Okay, so this is the supplemental video for section 6.9 in pre-algebra, indirect measurement. Um, so what indirect measurement is it's a process that allows us to use similar triangles to find measurements we can't find directly. Um, and so this is something that's actually a pretty old technique. In fact, if you ever see surveyors, those are people like that are have a tripod out and they're looking in their little what looks like a monocle or monocular, I guess, one single thing, and then they're see what's going on. They're using triangles to figure out how high or how low the ground is raised or declined. So it's used quite a bit. The book has just kind of a sample of problems that it works through. So the first one they call is shadow reckoning, and that's using two objects and their shadows to find similar triangles and find similar measures. So here's well, let's not look at that. This is number 1 from the worksheet. Where's our shadow one at? Yeah, number 8 here. Number 8, number 10. These are the two shadow problems. We'll start with those. So the May Road apartments in Hong Kong cast a 90-meter shadow at the same time. A 1.5 meter tall tenant casts a 0.75 meter shadow. How tall is the apartment building? What they're kind of doing a lot of times with problems like this is here's the building. Okay, here's its shadow. And then here's our person who's 1.5 meters tall. Okay, very thin, unfortunately shaped person. And his shadow is 0.75 meters. And what's going to happen is like the shadows kind of overlap and they meet at a common point. Now what this does for us is it creates two triangles that are similar. Okay, one is the building, x by 90 meters, and then one's the person, 1.5 by 0.75. Okay, so now what we're just going to do is just set up our proportion. X to 1.5 equals 90 to 0.75. And now we just cross multiply. In this case, we could use our calculators to make this work a little easier. 0.75 times x is 0.75x. 1.5 times 9 is 135. Divide both sides by 0.75. Pull out the calculator. And we get 180. Our units are meters, so what we're saying is that building is 180 meters tall. 180 meters tall. Okay. All right, another shadow reckoning problem that the book likes to use is number 10. Okay. So a man casts a 14-foot shadow. A 4-foot child casts a 9-foot 4-inch shadow. At the same time, how tall is the man? So again, kind of drawing this, we have a taller person casting some shadow that's, let's say, 14 feet. And we have a little child, and we don't know how tall the man is. We have a little child. And unfortunately, her body doesn't meet her legs. I don't know. I can't draw. And this is a 9-foot 4-inch shadow. And the person is 4 feet tall. Now, the reason I chose this problem is not because it's any harder to do than the last one. And let me try to hit the zoom here real quick, the focus, see if I can focus a little bit better. That's about the best I'm going to get. I'm not picking that one because of the fact that, like, another shadow problem. It's because of the units, really. Let me zoom in. That might make things a little better. Yeah, we've got all the information we need now. So, yeah, that's a little better for you. Zoom once more. Autofocus, I mean. There we go. So, we just know now that we got to set this up. But the problem is the 14 feet is comparable to 9 foot 4 inches. So we have to do one of two things, and it's up to you. You have a calculator, so it doesn't really matter. But you can convert this to mixed units, like 9 foot something fraction of a foot, which actually, if you do that, 4 inches over 12 because that's what a foot is. It's a third foot. So you have 9 1/3 feet. Now the problem I have with that is that a lot of you guys are crazy about using your calculators. You'll throw it in there and you get 9.33333 feet and throws your answer off. So what I'm going to do instead is I'm going to convert everything to inches. 4 feet, and I know 1 foot, equals 12 inches. So 4 feet will equal this times 4, because 1 times 4 is 4. 12 times 4 is 48 inches. And 14 feet, I'll multiply that by 4, or sorry, by 12, which gives us then, just use our calculator. So this I'm doing late at night. I don't have the mental math skills at the moment. 14 times 12, 168 inches. Now this guy is a bit trickier because I have 9 feet and 4 inches. So that's going to be 9 times 12 for that, which is 108 inches. But then I have to add on the extra 4, so plus 4 inches gives us 112 inches. Okay. So now if I redo this problem here, I know I have x height to 14 feet, which is really 168 inches. The other triangle is 48 inches to 112. And now we set up a proportion. X over 48 equals 168 over 112. I'm sure they reduce, but again, it's this case you're just going to throw in a calculator anyway. Cross multiply 112x and then 48 times 168. Gets us 8,064. And then divide by 112. Solve for x. Which is 72. Now don't forget, we converted this all to inches, so the man is 72 inches tall, not 72 feet. That's insane. If I want to know how many feet that is, divided by 12, and that gives us that he is 6 feet tall. So 72 inches or 6 feet tall. All right, another problem then. Okay, another problem. Number 3. Okay. So number 3 from the worksheet. So the triangles below are similar. How far is Dora's house here to Michaela's house? Okay. So we've got to figure out is how far is it from, how far is it from here to here? Now, in order to do this problem, we have to bring back some old math we haven't talked about for a while, and that's the Pythagorean theorem. Okay, actually I just paused it. I don't know if you noticed there's a change real quick. I had to go back and look at the answer key. There's a typo here. And I'll tell you in class, and if I don't tell you then I apologize, but I'll tell you in class on Friday. So if you're looking at this afterwards, hopefully you already have this fixed. They messed up. In the book, they didn't mean for this to be 4.8 here. They meant for this to be 4.8 miles, which makes a lot more sense because when I zoom in on the drawing now, these two guys correspond, and as does this one. And here's the missing length. We need this distance. Okay, so I apologize. Hopefully I told you in class. If not, sorry. So now we're going to set up that 4.8 corresponds to 3.2. And x corresponds to 2.8. I could try to reduce. This actually does. They're both divisible by 4, or 0.4. But again, throw in a calculator. 4.8 times 2.8. gives us 13.44. 3.2 times x is 3.2x, and then divide both sides by 3.2. So 13.44 divided by 3.2. We get 4.2 for x. Now, the problem is that is not the distance from Dora's house to Michaela's house. Michaela's house is right here. Dora's house is right here. This guy is 4.2 miles here. So the distance from Dora's house to Michaela's house is actually 4.2 plus 2.8, which is 7. It's actually 7 miles from Dora's house to Michaela's house. So if you just said 4.2, no, that's not the answer in the question they wanted answered. Okay, last problem real quick then. Probably the easiest one actually we're going to look at. These two triangles are similar. This is number 1 on the worksheet. The question is, what's the value of x? Well, they've given you the markings. 15 and 63 correspond because they are both between the two, the double and the single. So 63 over 15. 12 and x correspond because one, they're the only two left, but 12 is next to the double and x is next to the double. So x over 12 because 63 and x are on the same circle, on the same triangle. You can divide both of these by 3. This gives you 21 over 5 equals x over 12. That does make it a little bit easier to multiply then. 5x equals 21 times 12. 5x equals 210 plus 42. 252. Yeah. And then divide by 5. We get x equals 50 and 2/5, or 50.4. Yep, let's make it sure. And our units are yards. Oh, I'm sorry, I'm off the screen here, aren't I? So 50.4 yards. And there we go. That's the video with 4 problems from the worksheet. All right. I won't be at school on Monday because I have well, this is in 2014, so if it's 2015, I use the same video again. I will be at school, but I won't be at school Monday because of the conference I'm being gone to. So hopefully this helped you get caught up. If not, come in the morning before school, see Mrs. Deal. She would be more than willing to help you out, more than capable. All right, thank you.